Hello everyone, welcome to our presentation of real-time monitoring and control power distribution system with smart meter to support smart grid. At first, I would like to thank our honorable advisor Dr. A.K.M. Abul Malek Azad. Here are four group members, MD Motiour Rahman Naim, Fakhrul Islam Mahmud, Tanver Jahan, Ashiq-ur Rahman. Here is the outline I am going to follow. At first, I am going to talk about what smart meter is, then our energy meter, then GSM database and storage, then display monitor, then security and future work. Then you will be shown a video demonstration. So what is smart meter? Smart meter is a next generation device with two-way communication and better power distribution system. So the features we have are the real-time usage and information available for customers both in meter and display servers. Security lock only for admin access. Distributors company has control over smart meter remotely. Usage history is stored in SD card for future backup. Sending real-time data to power distribution center through GPRS. Observe usage of different rooms separately. Control over overcurrent limit. Here are the equipments that we have used. We have used Arduino Mega, Arduino Uno, SIM900A, fingerprint sensor, SD card module, relay, current sensor, adapter, keypad, 20x4 display. Here is the overall block diagram of our project. Here you can see we have used two microcontrollers, Arduino Mega and Arduino Uno. Here is our GSM. Here is our SD card. You can see here this is our current sensor A712. This is our voltage sensor. This is the adapter that we have used to power up all our DC components. And this big box is our main meter, and this small box from wire connection to Arduino Uno is our secondary motor. Here is the overall flow chart of our project. Here what Arduino Mega does is it starts, gets permission, it initializes, it reads data from SD card, then it goes for a 1 second loop. Within this 1 second, it calculates the average of VRMS, IRMS, power factor and I1 RMS. I1 RMS stands for room 1 current. Then when 1 second passes, it again calculates those average values and calculate the power and unit and cost. It saves data, passes data to LCD to show to the display, and then it sends it to the Arduino. Now what Arduino does is it starts, then initialize, then checks if any JSM data is available. If JSM data is available, it works accordingly. If no data is available, it checks if any data available from Mega. If any data is available from Mega, it receives that data, print it to LCD and uploads it to server. And then it goes to check if the current is over 3 ampere. If current is over 3 ampere, then it trips the circuit and then checks the keypad status, what users want to see. Then it again goes into a loop. Now here are some parts of our code for our Arduino Mega. These are the library that we have used. We have used software serial, wire, SPI, SD and liquid crystal library. Here are the variables, at least some of the variables that we have used. This portion of the code indicates the verification of fingerprint sensor. This portion of code indicates the value we are reading from SD card and writing on it. This part of the code indicates the getting the sample for current and voltage, and this part of the code sends the data to Arduino Uno via wire library. Now this is the code for our Arduino Uno. Here you can see the library we have used, software serial, liquid crystal, keypad and wire. These are the variables that we have used on some of the variables that we have used on our Arduino Uno. This is the GPRS this is the GPRS part of code where the GSM module sends the data to our server. This part of code receives the data sent from Arduino Mega, and this part of the code shows the data when the key is pressed. Now let's talk about our energy meter. We have used an optocoupler on our energy meter. This optocoupler is used in voltage sensor. We have used optocoupler to isolate our main meter from the power line. Here is the circuit diagram you can see that we have used for our voltage sensor. This is the current sensor that we have used, ACS712. This is the circuit diagram. This is the method that we have used. We have calculated the peak values of voltage and current and then multiplied it with 0.707 to get the RMS value. This is the way of getting power factor. We calculate the zero crossing delay of our voltage and current, and then we from that delay we multiply it with pi f2 and then get with theta, and then we calculate the power factor from using the cos theta. This is the oscilloscope graph we have got from our meter. This is a resistive load. This is for resistive load. As you can see, the peak are all almost same, so we can get the power factor of 1. This is our inductive load power factor, leading power factor. So for our unit calculations, we take samples for 60 milliseconds, then we average those RMS values and power factor, then it goes for 1 second in a loop, then we average the RMS values and power factor, and we calculate power from Vrms multiplied by Irms multiplied by power factor. This is in watt. Then we get our energy for this 1 second by using this equation. This is the GPRS GSM model we have used, SIM900A. We have used this module to send and retrieve data from server and control tripping operation. This is the working diagram. The meter sends data to server and user can access to the server from internet. We have used server to log data online, to get information remotely, allow utility office to control the smart meter remotely, to establish two-way communication. The server type we have used is a TCP server. Its main protocol of Internet Protocol suite, operated in the initial network implementation, provides reliable, ordered and error-checked delivery of data. This is the software we have used, socket test. Here you can see this box shows the data that is sent from the GSM, and this is the message box. From here you can type the command you want to send. This is a snap of our socket test when the values are uploaded there, data logging. This is a working diagram of the server. The meter through the GPRS sends the data to internet, and through internet it goes to a PC on a remote server and sends data, saves data there. And when it has to retrieve any command, it just get the data from internet through the server PC that we used. SD card module, we have used this one. We have used this SD card module to store real-time data, to provide backup and at the time of sudden power cuts. This is the flowchart that we used. We have saved, at first we check if any saved data is available. If any saved data is available, then we read the data from save and then write it to backup, and then remove the save, and then write it to data logger, and then write it to save, and then remove the backup. And if saved data is not available, then we read it from backup, and then we goes into this part. Display monitor. We have, as you know, we have used two displays on our meter. One is main meter display, and one is secondary display. The main meter goes to the basement of the house, and the secondary display goes to the user's room through a wire connection. Here is the flowchart that we have used. At first we start, then initialize the display, and then display the template, and then it checks if any I2C data is available. If any data is available, then it stores the data into variable and goes on a loop. And if data is not available, then it checks if any key is pressed. If any key is pressed, then it stores the pressed data into a variable pressed, and then it checks if pressed is 1, 2 or 3. If it's 1, 2 or 3, it works. For 1 it shows data for room 1, for 2 it shows data for room 2, for 3 it shows overall data, and then it again goes back to checking if any wire connection is available. If no wire connection is available, then it goes again to checking the I2C available. Here is a snap of our main meter monitor and display and secondary display of our room 1 with room 1 tab. Here is the overall tab. Fingerprint sensor. We have used fingerprint sensor with only one authorized admin access. We have used this fingerprint sensor for security purpose. Now future work. In future work, we are planning to include gas meter with our smart meter. We have also planned to use prepaid system in our smart meter. Now you will shown a video demonstration. Let's look inside of our smart meter. Here you can see these are the input line of our meter. Here you can see the room 1 and room 2 level. Room 1 goes to the load with room 1, and overall goes with the overall load. Now here you can see this is our fingerprint sensor, and this is our display, and this is our secondary monitor. Now let's look inside. Here you can see, here this one is our Arduino Uno. Here you can see Arduino Mega. This is the SD card. Here you can see the GSM module. This is the circuitry for our display, and here you can see two power adapters that we have used to power up our GSM and Arduinos, all the DC components actually. Here you can see the transformer that we have used, 220 to 12 volt step down transformer, and here is our optocoupler and voltage sensor circuit. You can't see it because of the wires. Here this is our current sensor. This too is our current sensor, and here is the relay that we use to trip the circuits. And here is the overall view of our smart meter inner portion. Let's go to the secondary display. You can see a wired connection is established to send data to secondary display. Now video demonstration. You can see all the setups are done here. We have switched on the lights, loads. It takes 8 seconds to initialize the GSM. Now the fingerprint access is only for authorized person only, and this we have done is to show that it is secure. It will be replaced with a lock to locked with smart meter in future, so that no one can just open the meter box and make any changes. Here you can see Motiour's fingerprint access is denied, and Ashiq's fingerprint access is granted. Now the tabs. If one pressed in secondary monitor keypad, it will show the data of room 1. If 2 pressed, it will show the data of room 2, and if 3 pressed, it will show the data of overall data. Here you can see Ashiq is pressed 3, then it shows the overall reading, and when he pressed 1, it shows only the data for room 1, and again he pressed 3, then it shows the data of overall. Now the power supply is stripped for load more than 3 ampere. If the loads gets up to 3 ampere, it trips the power supply, and then the connection is re-established after 5 seconds. Here you can see the load is Ashiq is increasing the load. It's 2.4 now, 2.99, and when it's over 3, the circuit is stripped, and after 5 seconds the circuit is on again, and as it is 3, the circuit is closed, and when Ashiq reduced the load, now the light is on. Now the power supply is stripped remotely from the GSM. If stop command sent to the GSM, the meter will trip the circuit, and if start command is sent to the GSM, the meter will again re-establish the connection. And here you can see we have used remote desktop connection to get the access to the to another PC remotely on the GDLN, and we are controlling it through remote desktop connection within this laptop. Now you can see when Ashiq types sends stop, the circuit trips, and when he sends start, the connection is reestablished. Trips again, and starts again. Here you can see a different setup to test our power factor. We have added inductive load instead of bulb box. Here it's a testing power factor is a lengthy process, as we get a stable value in 3 to 5 seconds. So we have included this chart to make it more clear to you. You can see when we are using resistive load, the error is almost 0%, and when we are using inductive value, it goes up to -2 to 3% error. Here you can see Ashiq is changing load, inductive load, the value of inductive load, and the power factor is changing accordingly. Now that will be all. If you have any queries, you can always send us email. This is the email of our 4 members. Feel free to email us if any question you have. Thank you.